let's get her done. Today, we're doing solving systems of nonlinears. All right. And to do that, we're going to use our goal substitution elimination for chapter 11.6. So let's giddy up. Now, it's always nice to know, hey, you're going to get, usually more than one answer. Sometimes you might get one answer, you might get two, you might get three, you might get four. Sometimes you might get none. It just kind of depends. But it's nice if you know what the graph is. So sometimes like that guy is probably a parabola stretched by units of 2. All right, you should know that, y equals 2x squared. And then this guy is probably a line. B is 2 up 3 over 1. So most likely we're going to find 2 intersection points. We're going to find an x comma y there. Okay. Now we can use substitution elimination. Sometimes you can't use elimination. Okay, but if I can, I would. All right. So I'm taking a look. This one is actually set up perfectly for substitution. I've got y equals 2x squared and y equals 3x plus 2. It's already solved for y. So what I can do is I can take this 2x squared and plug it right in there. So instead of y equals, I've got 2x squared equals, and then 3x plus 2. Okay, so I'm just using substitution, a little pluggy chuggy, and now I'm going to solve this thing. Okay, it's a quadratic. I got a squared term. So if I have a quadratic, we learn when solving quadratics, get your stuff equal to 0. So come on over, move this guy over. Now we got 2x squared minus 3x minus 2 right in descending order. So the power of x gets smaller and smaller. And we got 2x squared minus 3x minus 2 equals 0. And now we got to solve a quadratic. We got thousands of ways to solve quadratics. First one I would try is factoring. Teach me how to factor. Teach me how to factor. Everybody factor. Everybody factor. Show you when you factor. So do a little factoring. You could also use the quadratic formula here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You could do that. You could complete the square. Oh my gosh, don't do that. But you could. Okay, it would be nasty if you did. So let's go ahead and just factor this guy. I got factors of 2x squared. We know it's 2x and x. Now we got to come up with factors of negative 2 when you do outers and inners. The nose and smile of SpongeBob give you negative 3x. Okay, so go ahead and factor that. What are factors of negative 2 that give me negative 3x? Shout them out. What do you get? What do you guys get when you factor that?
Negative 2 and 1.
Negative 2 and 1. Where do I put the negative 2? Right here?
Yes.
And then 1 there. So check it. That's negative 4x. Do my outers and inners. That's 1x. Yes. Fantastic. Okay, so we get negative 3x. That's what I wanted. That's the OI term, that middle term. Okay. Now solutions for x. Remember, we just set each one of these equal to 0. If you need to, show the work. Set x minus 2 equal to 0 and solve it. All right. But from here, I would subtract the 1 over and then divide by 2, and I would get negative 1/2. And then I would add the 2 over and get 2. So you don't have to show the work. Okay. Just nice if you need it, do it. Now, that represents my x values, okay, of the 2 coordinate points where it's intersecting. So I have negative 1/2 and I have 2. Well, I still need to find the y values, okay? So when I plug these in, I want you to plug it into the linear equation. Okay, so plug it into the linear one. Number one, it's going to be easier. Number two, you don't have to deal with what we call extraneous solutions. So again, always plug back in. Always plug it into your linear equation. All right, so I've got y equals 3x plus 2. So y equals 3x plus 2. I'm going to plug in that 2. And then you guys can do that work. 3 times 2 is 6. 6 plus 2 is 8. So we get 2 comma 8 there. And then I'm going to plug in negative 1/2. So 3 times x plus 2. I'm going to plug in that negative 1/2. And if you want to put that in your calculator, you can. 3 times negative 1/2 is negative 3/2, or negative 1.5. And then negative 1.5 plus 2 is 1/2. Okay, so we get 2 answers there. All right, so again, my math lab's going to want coordinate points. Might have to put like a comma in between to separate them. So we should get negative 1/2 comma 1/2, and the other point is 2 comma 8. All right. Do we have any questions? Okay, so that wasn't too bad. Substitution, we did a little quadratic, solving a quadratic using factoring, and then pluggy chuggy again at the end. All right. About 20% of the way done. Let's finish up. Let's get the next one done. We have five that I'm going to go through today. So I gave you an example of substitution. Technically, I could eliminate, if I wanted to, I could eliminate my y's, multiplying the bottom one by a negative and then adding down. That would have worked as well. Okay. So when I look at example number 2, on top, I've got x squared plus y squared equals 4. Okay, if you know that's a circle. And then this one, you don't know what this guy is. This is also a circle. And that could be 2 answers. It could be 1 answer. It could be no answers. It depends on where that other circle is. So I've got x squared plus 2x plus y squared equals 0. So we're going to try to find out where these 2 circles intersect. Again, could be 2 answers, could be 1, could be none. I don't know. So let's try elimination. Okay. So when I take a look, I can eliminate the x squareds, but I can't eliminate this x. Okay, there's nothing up there in the blue one that will eliminate it. But I can eliminate this y squared. So the goal is to completely get rid of all the x's or all the y's. In this case, I can get rid of all these y's, or in this case, y squareds. So if I multiply this one by a negative 1 and send it through, no. I get negative x squared, a negative y squared, and a negative 4. And then when I add down with the pink one, this guy eliminates. This gives me 2x. This eliminates. And 0 minus 4 is negative 4. Look how nice and pretty that was. So using elimination sometimes is a beautiful thing. In this case, just divide over and we get x equals negative 2. So we got x value. Now we want to plug in for the y value. Okay. You can plug it into either one. If you plug it into the pink one, make sure you put negative 2 here and here. I probably wouldn't do that. This one's already set up nicely. So I'm going to go ahead and use the blue one up here. I'm going to plug in this negative 2, okay, for x. So I've got x squared plus y squared equals 4. Plug in the negative 2 for x. Simplify negative 2 squared. Negative 2 times negative 2 is 4, positive. And then I'm going to go ahead and subtract the 4 over. Now I've got y squared equals 0. And then I square root. Square root of 0 is just 0. So there's only one solution here. I get the coordinate point negative 2, 0. So what's happening is I have these 2 circles here. And they're intersecting right here at negative 2, 0. Just at one point. So sometimes you get 2 answers. Sometimes you get 1. Sometimes you get none. And I'm going to show you one where you get 4 answers. Okay. Any questions what I'm doing, everybody? Give me a thumb. Thumbs up, thumbs down, thumbs sideways. This is easy, Mr. Gotsch. Now, some of you guys might be like, why aren't I not using matrices? Okay. These are non-linear. Okay. So it means that we have parabolas and circles and all that stuff. You cannot use matrices here. Okay. Matrices are only for linear equations. Okay. Nothing with squareds. So we cannot use matrices. I wish we could, but we can't. We got to do this thing by hand. Okay. All right. So I take a look at the next one. As you guys know, elimination is one of my favorite things to do. And again, anytime I can, I will. And then I start talking like the Terminator, yeah. But in this case, you cannot eliminate. I cannot eliminate a y squared with a y, and I cannot eliminate an x with an x squared. So elimination, unfortunately, guys, for this one is off the table. We cannot use elimination. We have to use substitution. And this is actually set up perfectly for substitution because I already know what y is. I know y is x plus 2. So I'm going to go ahead and take that and plug it in right there into that blue y. Okay. So I've got x squared plus y squared equals 10. And where the y is, I'm putting in x plus 2 and squaring it. Okay. All right. Suggestions. Where do we go from here? What do we have to do? Use your chat. Use your microphone.
Multiply x plus 2 by 12.
Multiply x plus 2. Like that. What's that 4-letter F word we say in math class?
Foil.
Yeah, buddy. We got to FOIL this thing. Okay, so this is x squared plus, and then go ahead and FOIL this. So I get x times x is x squared. X times 2 is 2x. Do it again. 2x and 2x is now 4x. And 2 times 2 is 4. And that equals 10. Again, we have a quadratic, so we have this x squared. We want to get all of our stuff equal to 0. So I'm going to subtract this 10 over and then combine like terms. So I've got 2x squared plus 4x, and then 4 minus 10 is negative 6. From there, if you want to just factor that, you can. I noticed that these guys all have 2's in common, so you can either factor out a 2, or I just divide it out. It doesn't, you know, if it had a 2x in common, I would take out the 2x, but it's just 2, so you can just reduce it by 2. It just makes it easier to factor. So factors of negative 3 that add up to 2. What, 3 and negative 1? And then set each one of these guys equal to 0, and we should get x equals negative 3 and x equals negative 1. Okay. So again, you guys have 2 options to find y. Do not plug it into the nonlinear. In this case, I have a circle and a line here. Do not plug it into this guy. Plug it into the linear equation. Number 1, it's easier. Number 2, if I plug it into the ones with the squareds, then I'm dealing with, again, what's called extraneous solutions, and I would have to go back and check it into the linear one to see if it works. So if you're solving, only use the linear equation, okay? So I'm going to go ahead and use this pink one, and I'm going to plug in. So I've got y equals x, so negative 3 plus 2. Negative 3 plus 2 is negative 1. So I got negative 3, negative 1 for one answer. And then use x equals negative 1 to plug in. So I've got y equals x is negative 1 plus 2, and we got 1. So when we plugged in negative 1, oh, is that plus 1 there? Sorry, this should be plus 1. Let's fix that. Typo. Sorry about that. So x minus 1 gives us an answer of positive 1. When I plug in positive 1 plus 2, that's 3. So that's 1, and that's 3. Sorry about that. So final answer, I should get is -3, -1. And then this one gave me a positive 1. So when I plug in 1 plus 2, plugging it into this linear equation, I got 3. So final answer, -3, -1, and the other point is 1, 3. Okay. So again, this is graphically a circle and then a line intersecting. So we have some points here that they have in common. Okay. All right. Questions, ladies and gents? All right. We got 2 more left, guys, and we're done. We're done for 4 days. It's a beautiful thing. So I got example 4. So in blue, I've got 3x squared minus 2y squared plus 5 equals 0. And the bottom one in pink here, I've got 2x squared minus y squared equals -2. So when I take a look, what I'm seeing here is, can I do elimination? Can I eliminate the x squareds or the y squareds? That's the first thing I always look to see. I'm a big fan of elimination. I'm going to try to use elimination. It's easy to use, I think. What do you guys think? Can we eliminate something? Adam's saying yes. Joe's saying yes. What can we do? What do you want to multiply by? Give me your best Terminator voice if you want. Yeah, you can do it. Yeah. Get in the chopper. What do you want to eliminate? Terminate. What do you think? What do we need to multiply the top or bottom, blue or pink by? Bottom one by a -1. Close. It's going to be negative, but not -1. -2. Very good. Nice job. So the top one I'm not going to change, except I don't like the +5. I want this thing to stack up like a Wendy's double stack, okay? I want to get all of my x squareds, all my y squareds, all my constants here. So I'm going to go ahead and subtract that 5 over, and I'm not going to change anything else. So send it through. No. I get 3x squared minus 2y squared, and then I've subtracted the 5 over. So that guy just moved the constant over. My main man Joe said multiply by -2. Send it through. No. Everything gets multiplied by -2. That's -4x squared. Negative times the negative is a positive 2y squared. And -2 times -2 is 4. Okay, so this is great. An easy elimination one. This guy's going to cancel. 3 minus 4 is -x squared. And -5 plus 4 is -1. Okay, so go ahead and divide by -1. You get x squared equals 1, and then we're going to square root both sides. And I always hear x equals 1. And I go, Mr. Gotch always says, don't forget the plus or minus. Okay? So I've started that up, circled it. Don't forget the plus or minus. Anytime you square both sides, technically it's the absolute value, which means it's plus or minus. Okay? So, answers. This is where I'm at. I'm going to get 1 comma something, and I'm going to get -1 comma something. I got to find those y values. Now, in this case, these are both nonlinear. You guys probably don't know what these are. These are actually hyperbolas, which you guys don't know yet. Okay? So these are hyperbolas, and we want to find out what those hyperbola answers are for y. So you could plug it into either one. And I think the pink one's probably the easiest. Okay, so I'm going to use the pink one. And we're going to solve for y squared. So I'm going to plug in 1. And when you do this, just a reminder, please excuse my dear Aunt Susie. I don't have a Sally in my family. I have Aunt Susie. Sweet lady. So Aunt Susie says, hey, you got to do your exponents first. All right, so 1 squared is 1 times 2 is 2. Okay, if you multiply first, 2 times 1 is 2, and then you square, that's 4. That's too much. So make sure you do your exponents. So I got 2 minus y squared equals negative 2. I can go ahead and subtract that 2 over. I've got negative y squared equals negative 4. Switch the signs or divide by negative, and I get y squared equals 4. And then we can go ahead and square root that. So we get y equals 2. Well, Mr. Gotsch says, don't forget the plus or minus. So be very careful. So when I plugged in 1, I got plus or minus 2 there. Okay? And the nice thing is when you plug in negative 1, look at this. Plug in negative 1. Negative 1 squared is 1 times 2 is 2, and you don't have to do any of that work again. It's going to give you the same thing. Okay? So for me, this is okay. My math lab might want you to write out all 4 different answers. So they might make you do 1 comma 2 and 1 comma negative 2, negative 1 comma 2, and negative 1 comma negative 2. Just got to see what they're willing to take there. Okay, so this is 4 solutions on where these 2 hyperbolas are intersecting. All right, all right. Almost done. Any questions on this one, y'all? Last one. Let's do it. Last equation. I've got x squared plus y squared equals 10. That's a circle. And then this last one is x, y equals 3. Okay, so now again, I'm looking to do elimination if I can, but I can't eliminate x squareds with xy. I can't eliminate y squareds with xy. That's just not going to happen. So substitution is the only method I can use here. Okay. Now again, if I'm using substitution, I'd go back to this pink one and I would solve for either x or y. To solve for y, I'm just going to divide over by x. So I get y equals 3 over x. Okay. Now visually that helps me because I know that is a what we call an inverse function stretched by 3, and it's going to look like this graphically. So with the circle and the inverse function, there's probably going to be 4 solutions here. Okay. So we're going to find those 4 solutions real quick using substitution. We're going to take this 3 over x, and we're going to put it right there in the blue one. Okay. So I've got x squared plus y squared equals 10. But instead of y, I'm plugging in 3 over x. There's nothing really I need to FOIL here. I just got to take 3 and square it, which is 9. And I got to take x and square it, which is x squared. So what I see now is I got something nasty. I got a fraction in here. Okay, and I don't know about you, but I don't like solving things with fractions. So the little trick that we give you is we are going to multiply everything by the LCD. Now the LCD is this guy right here. Let me highlight it. We're trying to get rid of this x squared. Okay, we got to get that fraction out of here. So we're going to multiply everything by x squared. All right, so when I multiply both sides, I basically distribute x squared to everything. Okay, it's a little math magic. So I'll show you this magic in a second. X squared times x squared is x to the 4th. Here's the math magic. Go wave your hands. Do-do-do-do-do. and these guys disappear. It's magic. And now that looks a little bit more nicer to work with. Okay. This is a quadratic, so we want to get our stuff equal to 0. I'm going to subtract this guy over and write in descending order. And we're going to factor. What are factors of 9 that add up to negative 10? What are factors of positive 9 that add up to negative 10? Shout them out, use the chat. We're almost done, guys. Factors of 9 that add up to negative 10. Negative 9 and negative 1. Fantastic. Okay, now these guys can factor further. This is difference of squares. So this is x plus 3 and x minus 3. Okay, and this one right here is x plus 1 and x minus 1. So we actually get 4 solutions. We get x is plus or minus 3, and we get x equals plus or minus 1. Okay? All right, so if I want to plug these in, the one that makes the most sense is this guy right here. Okay, if you can avoid plugging it into this, that's going to avoid those extraneous solutions. Use the one without the exponents for x and y. So I'm going to take this y equals 3 over x, and I'm going to plug in 3 now. Okay, so when I plug in 3, I got 3 over 3, which is positive 1. And now I'm going to plug in negative 3. And when I plug in negative 3, 3 over negative 3 is negative 1. Okay, and I'm going to do the exact same thing and plug in plus or minus 1. So I'm going to take that 3 over x, and I'm going to plug in 1 now. So when I plugged in 1, 3 over 1 is 3. And now I'm going to plug in negative 1. When I plug in negative 1, I get 3 over negative 1, which is negative 3. So these are my 4 solutions that I got to type in. This is the 4 points of where the circle and inverse function intersect. Okay? And gang, I just gave you 5 examples, the different types you would see. I hope you took notes, because that's the type of questions you're going to see on your quiz. This is the type of questions you're going to see on your My Math Lab. And again, I hope you're practicing those. Okay? So ladies and gentlemen, that's what I got. I gave you 5 examples of chapter 11:6.